Welcome to the Potato Podcast. We keep it chill, raw, and a little fried. Just like a good potato. Sometimes deep, sometimes totally random. No filters, no fake vibes. Just real talk, weird thoughts, and good energy. Let's get into it.
Welcome to this deep dive.
Great to be here.
Today, we're sort of pulling back the curtain on a role that's just fundamental to everything now, even if you don't always see it, The software engineer.
Absolutely.
We're using a really detailed source here to get a handle on what it actually means to be a software engineer today, what's their day-to-day like, and where's the whole field heading?
Yeah, and it's fascinating because when you stop and think, software is this invisible force behind so much of what you use.
Totally, like my phone alarm this morning.
Exactly. Your phone alarm, checking your smart home gadgets, even, really complex systems in hospitals or banks. Software engineers built all of that. They're not just like typing code. They're designing and building the digital world we live in. So our mission here is to unpack that, really understand their role based on what our source material tells us.
Okay, let's get right into it then. Our source says, at its heart, software engineering is about solving problems, using logic, math, and structured design ideas.
And what I found really insightful is this focus on being a systems thinker.
Okay, what does that mean exactly?
Well, it's way more than just writing one little function, right? It's about designing the whole system, thinking about, okay, how can millions of people use this at once?
Scale.
Scale, definitely. And how do you handle errors so things don't just, crash? How do you keep data safe? And maybe most importantly, how do you build it so it can change and grow over time?
So it's this blend, it sounds like pure logic mixed with some kind of creative building.
That's it, exactly.
Yep.
That mix of rigorous logic and creative design is what makes it so intellectually stimulating and, well, vital. You're literally building useful things out of ideas.
Interesting. Now, to really get where we are today, maybe a quick look back helps. The history.
Yeah, good idea. The source traces it back to the mid-1900s, the very first programmable computers.
And back then, software was just something the hardware people did on the side.
Pretty much, yeah. It was almost an afterthought, often done by mathematicians or the engineers focused on the actual machines.
Okay.
But as computers got more powerful, the software got way more complex. It became obvious pretty fast that you needed a proper, structured way to build it. Like how civil engineers build bridges, You need a discipline.
Right, you can't just wing it when it gets complicated.
Exactly. And that need really started to come together in the late 60s.
That's when the term software engineering popped up, the NATO conference.
Precisely. 1968. That was a key moment. It helped professionalize the whole thing.
And since then, just constant change.
Oh, yeah. Huge waves. The source points to things like the dot-com boom. Suddenly software was in everyone's home. Then the mobile revolution put it in your pocket.
Right.
And now you've got AI and the cloud just transforming everything again.
It's really gone from being this, niche skill to something fundamental. The source calls it the new literacy.
That's a good way to put it. It underpins basically everything. How you learn, communicate, get entertained, even healthcare.
It's hard to think of an area it doesn't touch.
Mm-hmm.
Okay, so let's get practical. What does a software engineer actually do, day to day? How does an idea become a real thing people use?
Well, the source describes this workflow, right? It's a mix of really digging into the details, the analysis, but also exploring creative solutions.
So where does it start?
Usually with deep analysis.
Yeah.
Really understanding the problem. Who needs this? What are the limits, the constraints? And breaking that big problem down into smaller bits you can actually solve.
Okay, break it down. Then what? Design.
Then you get into architecture. Yeah. Mapping it all out. How will the different pieces talk to each other? The servers, the databases, the connections APIs, the thing you actually see, the user interface, how does it all fit?
Right, the blueprint.
Kinda, yeah. Then comes implementation. That's the coding part.
The typing.
The typing, yes.
Yeah.
Using the right language for the job, maybe Python for data stuff, JavaScript for a website, Swift for an iPhone app, But, and this is super important, writing the code. That's only one piece of the puzzle. A huge part is testing, rigorous testing.
Making sure it actually works.
And doesn't break anything else.
Yeah.
Think automated checks that run all the time. These things called CI/CD pipelines. They help automate testing and getting the working code out to users safely and quickly.
Okay, so build, test, then deploy, put it out there.
Exactly. Deploy it, often to these big cloud servers, using tools like Docker or Kubernetes to manage everything. But you're still not done.
Oh.
Nope. Then you monitor it constantly, using tools to see how it's performing. Are there errors? What are users saying? And you have to react fast if there's a bug or, an outage.
So it's a cycle. Analyze, design, build, test, deploy, monitor, and back again.
Got it. It's a continuous loop. The source really stresses that, it's fast-paced, you need amazing attention to detail, but the payoff is seeing even small tweaks make a huge difference when lots of people use your software.
Wow. Okay, when we talk about tools and what engineers actually build, it sounds like this field is just massive now. So many different kinds of engineers.
Oh, it's huge. The source lists a whole bunch of specializations.
Like what?
Well, you've got front-end engineers. They build the stuff you actually see and click on in your web browser or app, using frameworks to make those interfaces dynamic.
Okay, the visual part.
Right. Then there are back-end engineers. They build the engines behind the scenes, managing databases, creating those APIs the front end talks to, handling all the core logic on the servers, usually in the cloud.
The stuff you don't see.
Exactly. And then you've got dedicated mobile engineers for iOS and Android apps. Data engineers building pipelines to crunch massive amounts of information. Machine learning engineers creating and deploying AI models.
It keeps going, doesn't it?
Oh, yeah. That's just scratching the surface. You have DevOps engineers automating everything related to infrastructure and deployment, people building games, engineers writing code for hardware devices, embedded systems, and super important, security engineers trying to keep everything safe from attacks.
It sounds almost overwhelming, all these different areas.
It can seem that way. But the source makes a really good point. Even with all these different tools and specializations, there's a common thread, a shared way of thinking.
Which is?
It's this drive to build software that's not just functional, but robust, solid, elegant, secure, and really key, maintainable. Easy for other engineers to understand and work on later. That focus on quality kind of unites everyone.
That makes sense. Now, it's easy to picture an engineer just alone with their computer, right? But the source says it's actually deeply human.
It really, really is. I mean, think about it. It's super collaborative.
How so?
Engineers work in teams, often using these methods like agile sprints, short, focused bursts of work. They're constantly reviewing each other's code.
Code reviews. Is that just finding mistakes?
Finding mistakes, yes, but also sharing knowledge, suggesting better ways to design things. It's a learning process. Plus, they mentor newer engineers, and they have to explain really technical stuff to people who aren't engineers, like product managers or designers.
Communication is key, then.
Absolutely. And the challenges aren't always building the shiny new thing either. There's crucial work like writing good documentation so people understand the code. Or dealing with older systems, they call it legacy code.
The not-so-glamorous stuff.
Sometimes, yeah. And there's always this tension, right, between wanting to move fast, build quickly, and needing to be careful, making sure you don't break things for the people using the software.
So what makes someone a great engineer, according to the source, beyond just being good at coding?
Well, it highlights being an empathetic communicator, thinking ethically, like, what's the impact of what I'm building, and being resilient, a continuous learner, because the field changes so fast.
So the culture kind of has to reflect that. Openness, trying new things, always learning.
Exactly. That's baked into the culture. Look at the open source community engineers sharing code freely. Companies often have internal ways to share knowledge, too. The source basically says, in this field, what you're willing to learn next is often more important than the specific things you know right now.
That adaptability sounds crucial, especially when you look at careers. What kind of paths are there?
The source mentions two main tracks, generally.
Okay.
One is staying deeply technical, moving up from junior to senior, maybe staff, principal, even distinguished engineer. These folks tackle the hardest technical problems, design huge systems, make a massive impact through their technical skill.
Got it. The expert track. What's the other?
The managerial track. Moving into leadership. Maybe starting as a tech lead for a small team, then becoming an engineering manager, maybe a director, VP, even CTO someday. Focusing more on people and strategy.
Makes sense. Are those the only options?
Oh no. Lots of engineers move into product management. Some start their own companies, become teachers, consultants. And, some just love the craft of coding and do it brilliantly for decades. They don't necessarily want to manage people or systems at that level.
And compensation. The source touches on that too, right? High demand means.
Yeah, it notes that the demand and impact generally mean good salaries. In places like North America, 6 figures isn't unusual for experienced engineers. And for the top folks, especially in hot areas like AI, cloud, cybersecurity, the packages with bonuses, stock, remote work perks can be quite significant.
But it's not just about the money, is it?
Definitely not. The source really emphasizes other motivations, like the sheer intellectual challenge, solving really hard puzzles, and the satisfaction of building something real, something tangible from just an idea, and then seeing actual people use it and hopefully benefit from it. That's a huge driver.
That connection to impact must be powerful.
For sure.
So looking ahead, our source is pretty clear. This role isn't going away. If anything, it's becoming even more central.
Absolutely. And new fields are constantly pushing the boundaries.
Like what?
Well, think about quantum computing, a totally different way to compute. Or AI moving right onto your device. Edge AI, brain-computer interfaces, using computation to understand biology, bioinformatics. Engineers are needed at the forefront of all this.
Wow. But as software gets more powerful, more embedded everywhere, there are big ethical questions arising, right?
Huge ones. The source brings up some critical points, like how do engineers make sure the algorithms they build are fair, that they don't perpetuate biases? How do you protect people's data when privacy is harder and harder to maintain? How do you balance automation, which can be amazing, with keeping human control and opportunity?
So these aren't just tech problems anymore. They're societal problems, moral problems.
Exactly. The source frames them as fundamental questions for our future. And software engineers, they're right in the middle of it. Their design choices have real-world consequences. In a way, they're kind of writing the rules of tomorrow's world.
That's a powerful thought. So wrapping this all up, the picture we get from the source is the software engineer is like a modern polymath.
Yeah, I like that. A blend of scientist, artist, communicator, craftsman, all rolled into one.
They're this invisible force, the quiet enablers, the engineers of imagination, you could say.
Building these incredibly complex, robust systems that underpin, well, everything. In huge tech companies, tiny startups, nonprofits, governments, everywhere.
They've definitely moved beyond being just support. They're strategic partners in innovation now.
Totally. And the source has a great message for anyone listening who might be intrigued by this.
Yeah.
If you're curious, if you love building things, if you're a relentless problem solver, this could be a really exciting, really meaningful path for you.
And it feels more accessible now than ever, maybe.
That's a key takeaway the source highlights. The tools to start learning. They're often free, available to anyone. So much important code is open source. You can just go read it, learn from it. And the community is global and often very welcoming.
Right. So it leaves us with a final thought, a provocation maybe, for you listening.
Yeah, think about this. The future isn't written yet, and maybe, just maybe, you could be one of the ones to engineer it.